Just the slideshow and not presenter's view?
Yes.
Oh, very good. Cool. So this is a picture of my front yard rain gardens. You can put them in the front yard. Cindy really told you about me, so I'm not going to say much more about it. I'm just going to jump in and start. Yeah. If I can get the slide to advance. Bear with me. Here we go. All right, so here's what I'm going to talk about tonight for the next hour or so. I'm going to talk about what rain gardens are, why they're important, how they work. I'm going to talk about how to design and build one and how to maintain one. This is meant as an introductory kind of talk to this. I'll share some resources with you that you can look at afterwards. All these resources, and me and everybody who talks about rain gardens are stealing slides from each other. And so you'll recognize some of these slides on other sites and vice versa as well. So just sit back and aim for understanding, and then you can go back and study other materials later and really get into it deeply. So I want to start with just really defining what a rain garden is. At its simplest, it's just a depressed perennial bed. You know, sometimes we have raised beds, sometimes we have beds level with the ground. This one is depressed. And what we're trying to do is collect rainwater runoff off roofs or driveways or other impervious surfaces, put them into this bowl and infiltrate the water into the ground. And we populate them with native plants. And I'm not going to talk much about native plants other than the fact that they're really the only plants that can support wildlife in our region. So I want to talk a little bit about the problem. And the problem is we have a lot of impervious surface. We didn't in the past, but we have a lot of parking lots and developments and so on. And the goal has always been to get rid of the water. We treated water as a waste product. So off the roof, off the driveway, off the lawn, into the street, and into the storm sewer, and then into the river, and then into the lake. I don't know what watershed you're in, whether you're in the Lake Michigan watershed or the Mississippi River watershed. I suspect you're in the Mississippi River watershed. So we're, all that water's coming off those impervious surfaces, and in a typical year, at least in Southeast Michigan, where we get 34 inches of rain a year on average, you're probably close in Northeastern Illinois. 500 square foot roof will shed 10,000 gallons of water a year. And in the past, when the ground, when there was no impervious surface, much of it would go into the ground. Some of it would go into, run off the land into rivers and streams and such, but a lot of it went into the ground. And so if you look here on the right side of this diagram, where there is no impervious surface, the water, there are indentations where water will go into, the roots of plants will open up pathways in the soil, and the water would infiltrate in the ground. And you get a big rain, and there'll always be some runoff. Otherwise, there never would have been any streams or rivers. But on the left here, where you're looking at a built-up landscape, where there's very little infiltration going on, the streets actually act as rivers. And you get a lot more runoff than you would out of a natural area, as denoted by these two arrows. So being from Michigan, I have a aerial photo of Detroit here. This is Lake Huron up here. This is the Detroit River that connects Lake Huron to Lake Erie. And you can just see all the impervious surface in Detroit and the suburbs as well. And so all that water, which much of it used to infiltrate into the ground, are now going into the river. And so, it goes into the storm drain, and then the storm drains typically run straight to the closest river or stream. And so when we treat water as a waste and try to get it off our driveways and our roofs and so on, and we're trying to get rid of it, whatever is on your driveway or on your lawn goes in the storm sewer and ends up in natural areas where animals are trying to survive. And it's also your drinking water. And the kinds of things on your driveway and lawn are pesticides and fertilizers and grease and heavy metals and particulates and dog poo and all that kind of stuff. And it just gets washed into our waterways. In addition to this, there's this concept called flashiness. So the USGS has a river gauge or gauge for the River Rouge in Southfield, Michigan. And you can see that, it's just sort of moving along, and you get a rain and bam, the water level goes up really, really fast. And when that happens, it just washes away wildlife, or washes aquatic life in the river there very quickly. And it comes down pretty quickly, but not quite as fast. And doesn't really have enough time to recover until the next rain, where whoosh, it washes away. So with all the impervious surface, you have a much greater volume of water that is running into our rivers, in addition to the pollutants that it's carrying. So you can see in this picture just how scoured the sides here because of this outlet here. And here's a stream near where I live, and I live in the suburbs, but still there's a lot of impervious surface, and you can see the how the banks are eroded here, just from the water's trickling along here. Then all of a sudden you get a rain, and whoosh, you get a lot of water, and you can see it here in this picture. You can see the sediment coming out of the outlet here, and just in the color of the water. And so most of our stormwaters is untreated, and you get soil erosion and pollutants and flashiness. Flashiness, again, is the level of the stream going up, and you get increased water temperature. So most of our streams and rivers here are cold water streams with cold water aquatic life in it. And so imagine a 90-degree day with all this impervious surface and pavement, and you get a big rain. And, you get hot water poured into there as well. This is a picture of the Grand River going into Lake Michigan on the Michigan side of Lake Michigan. And you could just see all of the sediment running into the river. So most aquatic species need clear water, gravel, or cobble substrate, cool temperatures, and no pollution. And our built landscapes are doing the exact opposite of this, where the water's not clear, getting a lot of sediment in the water, we're increasing the temperature, and we're washing pollutants into it. So the goal is to start to try to mimic the natural hydrology, and instead of treating rainwater as a waste product, is to use that in our yards and other built landscapes. So you could do things like put a rain barrel off your roof or a cistern, but here's a picture of a rain garden where it's depressed and the water can come off the lawn. You could even put trees in rain gardens. There are many species of trees that will tolerate the water, things like black gum and swamp white oak and red maple, river birch will tolerate the inundation. And I don't know about where you are, but where we are, we're starting to put curb cuts in next door streets and run the water off the streets and put rain gardens between the street and the sidewalk. So the goal is to try to capture that water and send it into the ground. So when we're building rain gardens, we want to, usually when we build them, not always, but mostly we're taking water off a roof, sometimes off of driveways, less rarely or less frequently off a street. We want to keep them 10 feet from the house because particularly if you have a basement, you don't want to infiltrate the water and have it go into your basement. And then the way most houses are built, they're set up a little bit higher from the way the ground was graded, and so the ground slopes away. So we usually put a berm at the bottom there to try to hold the water back as we make the bottom of the rain garden flat. So that's a cross section. And rain gardens are typically only 3 to 6 inches deep. They don't have to be really deep. It has a ponding area, and in a larger rain event, the water will pond in there. But it's not a pond because the water does not stay in there very long. Typically no more than 48 hours. I have some rain gardens on my property that are in heavy clay soil, and none of them holds water for more than 48 hours. I would say none of them holds water for more than 24 hours. And so they're at no risk of breeding mosquitoes with standing water in them for that short. And the way they work is by putting deep-rooted native plants in. They open up pathways in the soil. So sometimes you see detention basins, and sometimes I get asked, can you put turf grass in a rain garden? And yes, you can. And it will infiltrate water very well for about 4 inches, which is the depth of the roots. But once it passes the root zone, then there's no root matter to open up the pathways in the soil. And so many of our native plants are very deep rooted, 3, 5, 10, and in some instances 15 feet or more deep. And so they're opening up pathways. So at a former house of mine, I had about a 75 square foot rain garden taking water off 300 square feet of roof in heavy clay soil. And when it was mature, we had a 3-inch rainstorm one night, and that rain garden did not overflow. It only overflowed the next night when we had another 1.5 inches of rain. So it took more than 4 inches of rain to overflow this rain garden. That was only 75 square feet, 6 inches deep, taking water off 300 square feet of roof. So the benefits of a rain garden is it helps keep water clean by filtering it and filtering the water. The ground will filter it before it goes back into the groundwater, and then the groundwater then will seep into rivers. They can help alleviate problems with flooding and drainage. I live in a watershed that, because of impervious surface, there's more water than the stream can handle, and so the city of Ann Arbor is putting many rain gardens between the street and the sidewalk to just try to stop that flooding. And so you're recharging the groundwater. Rain gardens are beautiful as well, and of course, since we are landscape, putting native plants in them, they provide habitat and food for wildlife. So here's some rain gardens that we built. Here's one in a backyard, and you can see the downspout over here. And the water just flowed from the downspout into this rain garden. This is second-year rain garden. This is the rain garden that I talked about that was taking, maybe 75 square feet and taking water off 300 square feet of roof from the house behind it. And just as a side note, that's a buffalo grass lawn that the rain garden is embedded in. And then that rain garden is back here. And then I asked the city, can I build a rain garden between the street and the sidewalk? And they thought it was such a great idea. They even came and drilled a hole in the curb for me. And you can see, and there's a storm, so the ground is a little higher over here. It's lower over here. And outside the field of view to the left is a storm sewer. So the water would flow this way. It would only hold about 1/3 of an inch of rain, but that was more than nothing. And then I even chipped out the asphalt a little bit here. So as the water ran this way, it would drop and then go in the hole into the rain garden there. This was the first street side rain garden in Washtenaw County, Michigan, not associated with a street repaving. And here's a picture of it from the other side. Here's another one. There's a long driveway to the left, and the water comes down in the driveway, and the driveway then slopes toward this rain garden, picking it up. There's another one taking water off this trailer over here, and there is a farmhouse to the left. And so we ran pipes under the ground into this rain garden. Here's one we did for a client. There's actually a culvert that comes out here. This is a second picture of a second-year rain garden. This is one we did for a client in Dearborn, Michigan. We didn't put that ugly edging on the side, and I'll prove that to you later. But this client loved the rain garden, and so who am I to judge that? And you can see the corners are a little bare because when we put the rain garden, it was actually round, and he squared it off and he started moving plants over into there. And I'm going to talk about this rain garden, the building of this rain garden a lot by way of example when I start to talk about methods. And this is the rain garden in my front yard. And it's well drained enough that I can put butterfly weed in it, which is an upland sand prairie plant. And here's another picture of that rain garden a little bit later in the season. And here's another rain garden in my yard late in August. This is my maize and blue rain garden. And so it's actually, there's a swale that runs between my neighbor's house over here and my house, and the water comes off our houses and it comes down here. And then it drops into the rain garden before it goes into the storm sewer over here. So those are some examples and pictures of rain gardens, and I hope you're convinced that aside from some of the ecological benefits of them, they can be beautiful as well. So now I'm going to shift to talking about building a rain garden. I'm going to talk about how big it should be, where it should go, and how deep it should be. I'm going to talk a little bit about digging and soils, and I'm going to talk some about planting. So, I write here there are 2 placement options, but there are really an infinite number of placement options. But at the extremes is close to the house and to a downspout. Again, not closer than 10 feet from the house. Or if you have the right kind of slope, it could be far away from the house. And you just need to figure out how you're going to get the water off the roof to the rain garden. Sometimes that's easy because the ground naturally slopes there, and sometimes the ground slopes off to the side and you have to do some piping. You don't want to put it over a septic system, of course. You don't want to put it where water already ponds, because you have poor infiltration, and you're just going to be, you're not going to be enhancing infiltration there. So sometimes the strategy is to pull the rain garden up the hill a little bit from where it's ponding and intercept the water before it gets there, and infiltrate it into the ground. Full apart sun is best, and it's not because we can't find wetland plants for a shady area. It's usually because of root systems of trees, making it difficult to dig and potentially harmful to the tree. So That's why you want to stay away from trees. Before you do that, though, you're going to want to conduct a Perc test just to make sure you have good infiltration. So you dig a hole 18 inches deep, fill it with water, let it drain, and then fill it again. And if it takes fewer than 24 hours to soak in, then it's a good site. You have good infiltration. One time, in one rain garden we were building at a house of a friend of mine who was transforming his house to net zero water and net zero energy. And so we were putting rain gardens in there, and it was very, very sandy soil. And because the University of Michigan is here, and they have a bunch of environmental programs, we were doing it with students. And the soil was very, very sandy. And I knew we didn't need to do a Perc test because I knew what the soils were. But for giggles, to show the kids how we do a Perc test, we dug the hole and we put a hose in and we turned the water on. And the soil was so well drained, it took 5 minutes to fill up the hole. And then it drained within about 2 minutes. And then the second time it took 3 minutes to fill up the hole, and it drained again within 3 minutes. So we beat the 24 hours. One time I went to a client and he wanted a rain garden, and I dug a hole and his groundwater was 6 inches below the level of the ground. And so the answer was no, we can't build a rain garden here because there's nowhere to infiltrate the water. So rain gardens can be any size. As I mentioned before, the rain garden I put between the street and the sidewalk in front of my house was, didn't really capture a lot of rain, but it captured some. So any size is better than none. But generally we size rain gardens based upon how much impervious surface there is. And of course, it depends on depth. The deeper the rain garden, the smaller it could be because you're increasing the volume. You can increase the volume either of water that it'll hold, either by making it bigger in 2 dimensions or making it deeper. If you have clay soil and not very good infiltration, then you might want to make it bigger. If you have sandy soil, then it could be smaller. And then, of course, the space-time, the space you have to put it in, the time you have to put one in, and cost are also important considerations. As I said earlier, rain gardens are typically only 3 to 6 inches deep because we don't want people falling into them and hurting them. And again, the deeper it is, the less surface area you can get away with, and the shallower, the more surface. So I want to provide a warning for those of you who have a phobia about math. We're going to get into some math. So practice your deep breathing, take another sip of wine, take another toke, or whatever you're going to do, whatever works for you to calm your anxiety if you're anxious about math. But what I want you to do is understand the concept. At least here in Southeast Michigan, pre-climate change era, 85% of our rain events are a ½ inch or less. You're probably very similar. And so what we're trying to do is capture that first flush of rain. And either, depending upon the standards in your community, that would be either the first ½ inch of rain or the first inch of rain. And basically what you're doing, so just understand the concept. We're calculating how much water comes off an impervious surface for a ½ inch of rain or an inch of rain. And we're digging a hole that's big enough to hold that much water. So I'll say that again. We're calculating how much water comes off the impervious surface and digging a hole large enough to capture that much water. So if you understand that, don't worry about the math. You can always come back to the math later and figure out how big to make it. So let's talk about an example. And let's say we have a roof area that's 15 by 20 square feet. That's 300 square feet of roof. And let's say we want to capture the first half-inch of water that comes off that roof. So the volume of the water, how much water is coming off that roof, the volume is measured in length times width times depth, and they all have to be in the same units. So 15 feet by 20 feet and a half-inch of rain, we want to convert a half-inch to feet. So that is 1/24th of a foot. So 15 times 20 times 1/24th is 12.5 cubic feet of water that comes off a 300 square foot roof in a half-inch rain. So if our rain garden is going to be 3 inches deep, then we need to take that 3 inches, which is a quarter of a foot, and multiply the number of cubic feet of water that's coming off of that to give you 50 square feet of surface. So off a 300 square foot roof, to capture a half-inch of rain in a rain garden that's 3 inches deep, you need a 50 square foot rain garden. If the rain garden was 6 inches deep, 6 inches is half a foot. So you take your cubic feet of water, you multiply it by 2, which is the inverse of a half a foot, and you get 25 square feet of surface. And that makes sense. It's twice as deep, so the rain garden can be half the size. So then, excuse me, so then you can make some adjustments based upon size. If you have sand, you can make it smaller. And I'm just estimating 33% smaller. If you have clay, you might want to make it bigger, maybe 33%. And, you just take just take a handful of soil. And if it crumbles like sand does, then you have sandy soil. If you clump it in your hands and you end up with a bunch of turds in your hand, then you have clay soil. So how long and how wide? So generally, when you have the water coming in, the house is up here and you have the water coming in, we typically make the longer side perpendicular to the slope. So, here's your downspout, the slope, this is the uphill part of the rain garden here. This is the downhill part. We generally make it perpendicular. Good rule of thumb is to make the length twice as long as the width. But you also need to consider the aesthetics when figuring out the shape. And so many times your rain garden, given where you want to put it, may not be a kidney shaped. And so you got to be creative about that. And so I also want to point out here, remember I showed you the cross section of a rain garden that we had the berm at the downhill. So here's the uphill portion, here's the downhill portion, and here you can see the berm. And since this is the most downhill portion, the berm is going to be higher here than the berm is here, and you'll probably have no berm up here as well to allow the water in. So let me talk about an example. So here was a client where we were going to take water from half the house, and half the house was 42 feet by 12 feet. And we were also going to pipe the water in from 2 different locations from the garage. So you can see in my notes here, here's the house. We're going to pipe water in from here. Here's the garage. We're going to pipe water in this way and this way. So, as I said, the house is 42 by 12. Each half of the garage is 25 by 11. So this half of the garage here is 25 by 11. This half of the garage is 25 by 11. So the first thing we need to do is figure out the volume of water coming off in a half-inch rain. So the house is 42 by 12. The garage, each half of the garage is 25 by 11, but there are 2 halves, so we multiply that by 2. So this area plus this area gives 1,054 square feet of roof surface. So for a half-inch rain, 3 inches deep, We want to first then figure out the volume of water coming off the roof. So 1,054 square feet, and a ½ inch of rain is a 24th of a foot. So 1,054 times 1/24 or divided by 24 gives us about 44 cubic feet of water. And so at 3 inches deep, which is a quarter of a foot, you take the volume of water and multiply it by the inverse of a quarter, which is 4. So the rain garden should be 175 square feet. Eventually, this rain garden was a 16-foot diameter circle, and the area of a circle is pi r squared. So 3.14 times the radius, which is 8 squared, gives, it turned out to be 201 square feet. So it was sufficiently large to capture a ½ inch of rain. And my slide is not advancing. So you might want to contact Miss Dig first, or whatever it's called in Illinois, to identify your underground utilities. You don't have to worry about a water line that's too deep. You don't have to worry about a sewer line that's too deep. Electrical lines are generally, if they're buried in the ground, deeper than that. But so really the utility you're most worried about is the cable and internet line. So you can define the borders using a rope or a hose and then mark it with spray paint. So here's the spray paint line for my rain garden in my front yard. And you can see it's not a kidney bean shape because I got a driveway. Let me go over to here. I have a driveway over here. I have the sidewalk here, they come at right angles. And then I have a bed over here with a curve in it. So I made this rain garden piano shaped. Actually has a 90-degree corner here to match up to the driveway and the sidewalk, and the curve in the rain garden here to mirror the curve here so that I could put pathways in. Just that pathway. So I was new to this house, and so this was one of my earliest endeavors in getting rid of my lawn. So then you start to dig it, and you're building your berm, and here it is from both angles. Here's your down edge berm, but it's really just a 2-dimensional cross section. So you can see as you move up the hill here, the berm gets shorter and shorter. It's to the point where you don't need a berm up here anymore. And you can see that here, your berm, your berm is taller here than it is here. So what you're doing, so if here is the slope of the land, and you got a level across here, you're going to start digging over here, and you're going to take this soil and move it, and you're going to move it over here to start building your berm. And then that berm gets smaller as it moves up the side. And so here's the post picture. This dotted line shows the original slope of the land. So you did a lot of digging over here, but no digging over here. In fact, you added soil with the berm over here because of the slope of the land, because you want the bottom of the rain garden flat. So this berm here, looks like a lump. We generally feather them more, and I'll show you an example just so it doesn't look very obvious. And then you want to compact it and plant it so that it doesn't erode. So one of the tricks we've done is when we're putting turf grass on the berm is we'll just peel the turf grass back and then shove some soil underneath here. So here is the sod peeled back at the down edge sides. And here's the rain garden after it's built. And you can maybe make out the berm here, and then you could see very clearly that it's dug over here, but this is level. These yellow flags are for where the dog fence was, and we did cut it when we built the rain garden, but I didn't want to cut it again when we were planting. Here's another example. So this one is a kidney bean shaped rain garden. So we started digging here, and we knew because of the slope of the land, we were going to have to put a couple layers of, we use the soil from here and do it and put it here. So we put the first layer of sod down upside down. And then you can see a second layer of sod dug. And here's the second layer there. And then we started digging some more sod. And then we put a green side up here for the berm. And I'll come back to this, but you want to make the bottom of the rain garden level as you're digging it. So we use stake, string, and a line level. You could use a 2x4 and a carpenter's level. And sometimes at the end, we'll add water and rake the soil fast to get it level. But typically we're using a line level as shown here. So we put a stake at either end, and we try to get that string level. So here you could see we put a number of stakes and put a number of lines out there and leveled them. So if you look at this stake here, the close one, and this one over here, this line is level, and you can see there's much greater distance between the string and the ground over here, and follow string here, and there's none here. So what that means is we need to dig this out to get this ground level. Otherwise, the water is going to come in here, and it's just going to flow all the way down to here, and then all of your water ends up down here, and you're losing the opportunity for all of this ground here to infiltrate water. And we just started the digging there. So coming back to this example, you can see we're now starting to dig a little deeper over here on the left and using that soil to feather this berm so that it looks very gradual. And here we're digging some more ground over here and continuing to feather it. And now we're taking out some more sod and putting that sod onto that soil that is being feathered. And now there's no more sod inside there. And as we level this, then we just take the soil here and we use it to feather this, this berm some more. And there it's pretty much level in the bottom. And so, you don't, in that picture, not the picture, but in the diagram I showed before, it showed a pretty obvious bump for a berm, but we don't do that. We want to make it as gradual as possible. So you can't even really tell that the rain garden is depressed any. So going back to that example of taking water off the garage and the two places off the garage and from the house, this was pretty level. So we rented a sod cutter to take out the sod, and you can see that we're flipping the sod upside down and laying it, trying to feather it. Here's a better picture of that. So we have like 2 layers of sod here. Then there's a narrow layer of sod here with a layer on top here. So then you get kind of like a layer and a half. And then here you have 1 layer, and then it just sort of melds into the surrounding turf. And there's what it looked like when it was dug and the berm was built. So let's talk a little bit about soils. There are a lot of resources that talk about amending soils. I'm not particularly fond of it, of amending soils in most instances, mostly because I'm lazy. and and you don't have to. So if you have really sandy soil that infiltrates well, you don't need to amend the soil. It may even drain well enough that you could put in sand prairie species, dry sand prairie species. If you have a loamy soil, you also don't need amendments. If you even if your soil is clay and your Perc test passed, you generally don't have to amend the soil. But if you have a lot of really compacted clay and your Perc test failed, then you're going to amend the soil, and you're going to use a 50-50 mix of compost and sharp sand. So if you're going to build your rain garden 6 inches deep and you have to amend the soil, you're going to have to dig it out to 18 inches. And then you're going to put in 6 inches of compost and sand, and you're going to try to mix it in with the layer below that. Then you're going to put another 6 inches of compost and sand. So you bring that up to the 6-inch depth. So that is a lot of work. It's 3 times as much digging, which explains why I don't like doing that. But in most instances, that's not necessary. We rarely we rarely amend the soil. I'd say in about the 60 rain gardens we've built, maybe 5 or 7 of them we have amended the soil. So now let's talk a little bit about getting water from the house to the rain garden. So in this picture here, you can see an orange line painted. The downspout is to the right here. And so the water does not naturally flow from there into the rain garden. So I just painted a line where an underground pipe would go. And I'm jumping back and forth from examples because I have better pictures from some examples and better pictures from other examples. So this is from an example you haven't seen before, but this one is from the circular rain garden. And so what you do is you generally cut off the downspout and you get an adapter from the size gutter you have to 4-inch corrugated plastic, not perforated. And then you run it to the rain garden. So what we do is, you can see the spray paint in the grass here, is we then strip the sod, lay it off to one side, continue to dig the hole, put that soil to the other side. Then we put the soil that we can back in, put the sod back in on top of that. And if you do it well, you won't know that, once the spray paint wears off, you won't even know that there's the pipe under that. Here's a different example of that. You could see the pipe coming out here. We usually put some rocks at the bottom of the pipe so that if the water comes gushing out, we're slowing the water down. But we dug this out, and the sod is back in, and we have a little bit of extra soil left, which we spread out on top here, and we threw some back in the rain garden. So let's talk about planting. So you're going to choose native species, of course, because they're adapted to our climate and soils. You want to have a rough plan. You could do it a couple different ways. You could group species together. So, have a mass and a drift of one species in one spot, a mass in another spot, a third species in a third spot. Or you can intermix it for a more naturalistic look. And generally plan to put plants in every 1 to 2 feet. So you suppress weeds. I should change that to 12 to 18 inches. I generally do not advocate planting as far apart as 2 feet. And then a couple inches of mulch, but don't cover the crown of the plants. And then you're going to want to water it immediately, and an inch of water per week until the plants are established. That inch per week can come either from the sky or from a sprinkler of some sort. So so some tips is, rain gardens are a functional thing, but they should be beautiful as well. So think about your planting plans. consider plant height, bloom color, time of bloom, and leaf texture. Use plants that bloom at different times so you have a long flowering season. Use sedges and grasses. Many are attractive, and now we're actually doing matrix plantings where half of what we put in a rain garden is a sedge, for that ground layer. And then you may need some help choosing species from someone familiar with building rain gardens, and don't use seed because the seed's going to float all over the place, and you're going to have you're going to have really dense plants at one end and maybe nothing at the other end. So here's that round rain garden, and you can see how we grouped species. Here we put blue flag iris, here we put blue lobelia, Culver's root over here, Ohio goldenrod, swamp milkweed. And we have an inlet here, we have an inlet here, we have an inlet here. So basically from about 1:30 to 8 o'clock, we put in wetland species because they're very close to the inlets. And then from 8 o'clock to 1:30, we actually put in upland species because in a very light rain, this top left section of the rain garden may only get water from the sky. And here's what it looked like when it was done. And you can see here the orange line from the sod that was put down. And if you can sort of wish away and not see that orange line, you can't see that there's a pipe there. And here it is from the other standpoint. You could see the other downspout over here. You can see a little bit of soil around the sod there. And here's what it looked like the next year. So you see, it was round when we were finished with it, and he squared it off. But that's what it looked like in year 2. It looks fabulous. So sometimes you're on a slope, and if you're on a slope, then the uphill part of the rain garden might have to be really, really deep. So what you do instead in those situations is build the rain gardens in terraces. So in this particular example, there's water coming out of a culvert here. And it slopes pretty dramatically. It slopes a couple of feet. And so you can see we essentially built this rain garden as 3 tiers. There's one here with a berm over here. And so when this one fills up, the water flows over the berm into this pool here. And when that one fills up, it flows over the berm into this one over here. And here's a side view of that. We actually weren't even quite finished planting yet, but you could see the berm here and a berm here. And this is what it looked like when we were done. And this is what it looked like the next year. And he loved it so much, he had us come in and put in another pool the following year. So you can see here the little, where'd my cursor go? Over here, you could see the little bridge, and here's the next pool after the bridge. Here's my front yard rain garden right after planting. This would be a May picture. Yeah, my crabapple there is in flowers, so this would be mid-May picture maybe. This is it in July of the same year. And here it is the following year. And almost no, just pathways of grass in the front. Here's in this particular case, these people wanted to, rain gardens are more expensive and labor intensive to build than a perennial bed, because perennial bed you just planted at the surface of the ground. But the rain garden was smaller than the perennial bed these people wanted in their front yard. So what we did is this isn't a great picture, but the rain garden, the whole perennial bed comes out to here, but just this section of it here in the bottom right is the rain garden. And maybe you can see it here. I lost my cursor again. There's actually a berm across here. So this is the rain garden right here. And then back in here is the rest of the perennial bed. But it's very subtle. And you wouldn't notice, you know, when the plants are grown up that this, that there's actually a rain garden there in a depressed bed. Let's talk maintenance. So year one, you want to make sure it gets an inch of rain a week. May have to do a little weeding depending upon how much mulch you put down. You really shouldn't have to do much weeding at all. Year two, you generally don't have to water, only if you're having some pretty serious drought and or the plants were installed very late in the first season. Maybe a little bit of weeding. Year three and beyond, infrequent weeding. And then in general, for habitat, leave dead plant material up at the end of the season. There's some winter interest, and it provides places for all those insects you nurtured over the summer to overwinter. And then in the spring, you can cut it down or burn it and never use any fertilizers. So since prescribed fire is one of my favorite things, I'm going to show you, you know, you shouldn't burn your rain garden every year, but, you know, every third or fourth year be a good thing to do. It will enhance the biodiversity. Species that may look like they're dropping out will pop back in by burning it. All these plants are adapted to fire. So here's this rain garden before the burn. Here it is while we were burning it. Here it is after we burned it. And there it was that season, that same season, a little bit later. So let's talk money. If you did it yourself with purchased plants, figure maybe $3 to $5 a square foot, maybe some more if you have to rent some equipment, even more if you have to do soil amendments. If you have friends coming to help you, it may cost you a little pizza and beer. If you hire a contractor to do it, it could be really variable. Maybe $10 to $12 a square foot. And of course, more if you need soil amendments. So some frequently asked questions. Does a rain garden form a pond? No, the water infiltrates the ground pretty quickly. And in between rain events, the rain garden could be pretty darn dry. Is it a breeding ground for mosquitoes? No, because it takes 7 to 12 days for mosquito eggs to hatch. And the rain garden is not staying, it doesn't have water in it for that long. Does it require a lot of maintenance? Well, it depends what you think of as a lot of maintenance. Some people don't want to do any weeding. Some people love to weed. And then is it expensive? That of course is dependent on each person. It depends on your resources, if you do it yourself or if you hire somebody to do that. So here are some resources. You can take a screenshot of this. I'll give you a moment to do that. And then I will entertain questions. And I have not been looking at the chat.
No worries. I got it.
Okay.
One of the early questions was someone was asking if they saw rattlesnake master in the rain garden.
Yeah, look at that picture there. That's up there right now. There's rattlesnake master in it.
Yeah. So yes. For those of you that are wondering if the session is being recorded, it is, especially since there's a lot of technical information about figuring out the actual size of your rain garden. So you can look at it again. It'll be on our website on our Learn and Grow tab. And then, let's see, any suggestions for tree roots in the area?
Don't plant your rain garden near tree roots. That's like all I got. Don't plant it near tree roots. I mean, don't build it near tree roots.
Sure. Do you, what suggestions would you have for trying to capture the water from sump pumps? Is that, it comes out with a little more force than from a gutter and downspout. So what are some of the considerations for that?
Yeah, you can absolutely do it with sump pumps. And in fact, one of the examples I showed you, I didn't mention it there, was actually water coming from a sump pump. The picture where I showed the rocks at the bottom of the pipe, that was actually coming out of a sump pump. We do those periodically. The challenge with a sump garden is how much water is it going to get. You know, it's variable depending upon whether it's a wet part of the year or not. Typically a sump pump, each discharge, I think at least on my sump pump, I measured 5 gallons. So if it's, you can figure out in a day how many, you know, based upon how many discharges you have, the volume of water, you know, there's a formula for figuring out what the volume of 5 gallons is. But then, you know, when it's rainy, you know, might go off every 20 minutes. If it's dry, it might go off every 2 days or longer. So the city of Ann Arbor requires, if you put a sump pump in, requires a rain garden, and they're saying 50 square feet. We built a couple of them at 50 square feet that never seemed to get any water in them. And then we built one at 50 square feet that everything drowned because it was continually, it was a pond. It wasn't a rain garden. There was just water in it all the time. So the lesson there was it was at the bottom of the hill in an old stream bank in a floodplain. And so poor infiltration, but that's what the city required. They learned some lessons from that as well. But yeah, you can absolutely run your sump pump into it.
I think a lot of our plant species would be similar, but can you recommend some of your favorite plants for rain gardens? This is someone from the Chicagoland area. And just from looking at your pictures, a lot of them are exactly the same as.
Yeah, right. You know, there's got to be 95% overlap. In fact, rattlesnake master is native in and around Chicago. It is not native in Southeast Michigan. The range of rattlesnake master only goes into the southwest corner of Michigan, but close enough for me. But the answer is no, I can't recommend a list of plants for a rain garden, because if you have a very sandy rain garden that drains very, very quickly, you're going to put in, you could put in sand prairie species. You could put butterfly weed in it. You could put little blue stem in it. You could put lupine in it. But if you have a wet rain garden where the water doesn't infiltrate very well, none of those plants will survive there. And so you're probably going to put in wetland species, which wouldn't survive in the sand prairie, you know, in the sandy rain garden. So you have to figure out what your soil type is and how wet it's going to be, and you take your best guess at it, and then you go look at a native plant catalog and choose the plants that fit that. And I'm sure, you know, you guys are having plant sales, and I'm sure you have people that can help people with plant selection.
Yeah, and we use, I mean, you would, like you said, you would just really look at the requirements for the plant. And if you're expecting your rain garden to have standing water, that would be a whole different complement of, you know, or more standing water than easily drained, you'd have a whole different complement that you.
A very sandy rain garden may have standing water in it for 20 minutes, and that's it. And then the next day it's bone dry. So you can't put wetland plants in that. You got to put sand prairie plants in. And, you know, then you may have a rain garden that holds water for 24 or 36 hours. And you can't put sand prairie species in that. So the short answer is no, I can't give a definitive list. Sorry.
How
I
far?
wish it were that easy.
Yeah. Well, it depends on the plant. How far away from a tree should the garden be?
It should be outside the drip line.
And can you, for people that may not be familiar with what a drip line is, can you give us a quick definition?
The outer edge of the outer leaves. It's the place where in a rain you would get wet from the sky.
Let's see. This is
but you can build a rain garden and plant a tree in it. So you could plant a river birch in it. You could plant a red maple. You could plant a black gum in it. You could plant maybe a pawpaw in it. You could certainly plant a swamp white oak in it. So you can plant wetland trees in a rain garden. You could also plant shrubs in a rain garden. You could put 9-bark in it. You could put red osier dogwood in it. There are plenty of shrubs. So they don't have to be perennials, grasses, and sedges.
Our next question. These people have a rain garden with a dry creek bed in an area that's constantly wet. They live in Chicago and have part clay, dense soil, and are struggling to keep plants and shrubs in the area. So the river birch, Siberian iris loves it, but turtleheads are struggling. The ivory halo dogwoods got mold last year, and can you suggest what to do with the plants as I'm struggling with roots that rot?
So if the roots are rotting because it's too wet, then again, go look at your native plant catalog and step up from or step down a level of moisture from the plants you have to the next level of drier species.
And someone, let's see. There's a direct message, and it's a share on a rain garden, and it's what we'll do is we will take a look at that and add it to our Learn and Grow page. On that page are a variety of resources. So if you need to watch Drew's presentation again and work through the math and then need some additional resources with plant lists, just go back to that Learn and Grow page that we have, and there's a lot of different resources that'll connect you up to rain garden manuals, planting lists, different species lists. I mean, like everything else, when you're planting something, it's going to take a little bit of research and time just reading through things and making your lists. And I think, let's see, I don't have any more questions. I think we're good. I think I answered or got you everyone's questions for answering. I didn't answer anything.
Well, great. Well, thank you for having me.
Thank you, Drew. And I found this particularly informative. I am usually one of those people that just wants to get started on a project without doing any of the math up front. So you're going to make me do some math before I put my rain garden in. But it works better. It becomes a more functional element in your landscape if you do the planning ahead of time. So, and I found your illustrations and photographs extremely helpful because I've never seen any, seeing your the construction in process was probably the best thing I could ever see. That really helped me understand visually how to tackle the projects. So thank you so much for that.
Cool. You're welcome. Thank you.
Thank you, everyone.
Bye.
Have a great rest of your evening and upcoming weekend, and happy gardening. Join us for Heather if you get a chance. Thank you, everyone. Good night.